Hello, and welcome to today's lesson where I'm actually going to go through and explain some of the harder word problems in this unit. So this is really a review of all of our material and looking back at some of the problems that you've seen and tried to work with in this unit. Okay, so looking at this first one, the volume of a cylinder is 628 centimeters cubed. Find the radius of the base if the cylinder has a height of 8 centimeters. Round your answer to the nearest centimeter. So in this situation, what you want to remember is starting with the formula. Volume equals area of the base times the height. Okay, we're given the volume, 628 centimeters cubed, and since all of these are centimeter measurements, when we're dealing with it mathematically, we don't have to tag in the units. Area of the base, pi times radius squared. We're given the height of the object, which is 8, and what we want to do is start taking off pieces as we go. So the first piece that I want to take off to get into the radius is the 8. So I'm going to divide both sides here by 8. 628 divided by 8 is 78.5. Equals pi times radius squared. And then our next step is we're going to have to divide by pi, because pi is an actual value. Okay, it's not a perfect value, but it helps us get to the end result that we're looking for. So we have 78.5 divided by pi. You want to use the pi button. Okay, if you're going to use an estimation, you want to go out a couple places, not just 3.14, but at least go 3.1415 to make sure that you're getting a fairly accurate value. Okay, in this situation, we've got 24.99. Okay, hopefully based on what you see here, you can do the estimation without even finishing this problem. Think back to one of our very first units when we were estimating radicals. 24.99 is extremely close to 25. So we know that if we square root both sides, we're going to get an R value that is not equal to, but very close to 5 centimeters. Okay, next problem we had here. A couple questions on this throughout the unit. Looking at when we take a piece of paper, we have two possible cylinders that we can make. We have a cylinder with a circumference of 8.5 inches, the short measurement of the paper, or we can have a cylinder with a circumference of 11 inches. So what we have to do here is understand that we do not have the radius of either of these circles. So since we don't have radius, we have to use our circumference formula, which is 2 pi r, and we have to use that in both situations to get the radius of these two cylinders. So I've got a circumference of 8.5 equals 2 pi r. So I have to divide both sides by 2 pi. Now, be very careful when you're typing this into your calculator. If you're typing it in all at once, you have to do 8.5 divided by parenthesis 2 pi to make this work properly. If you divide by 2 and pi after, I'll show a quick example here. 8.5 divided by 2 pi. If you type it in this way, the calculator is actually going to divide by 2 first and then multiply by pi. And that's what we don't want it to do. Okay, so you either want to do it as a two-step problem, divide by 2, enter, divide by pi, enter, or put the 2 pi in parentheses to make sure that you're getting that correct value. Okay, so we've got 8.5 divided by 2 pi. equals a radius of 1.35. Okay, we do the same thing on the other side. Circumference of 11 inches, 2 pi r. So we divide both sides by 2 pi to get the radius by itself. So now 11 divided by parenthesis 2 pi, close the parenthesis, we get 1.75 inches. Okay, now we have the pieces that we need to be able to find the volume of these shapes. So the volume of the first cylinder, pi, times our radius of 1.35 squared, times the height of 11 inches. And then we have our other volume, which equals pi times 1.75 squared times 8.5 inches. Okay, and then we're just going to type this all in. So pi times 1.35 squared times 11, okay, gives us a volume rounded to the nearest 0.1, our nearest tenth, is actually 63.0. Okay, the value is 62.981 when we plug that value in. But when the 8 rounds the 9 up, it rounds it to a 0, so that is rounded to the nearest 0.1 of an inch cubed. Now our other volume, we've got pi times 1.75 squared times 8.5. Okay, we get 81.8. Okay, so we can see there's a pretty big difference in the volume of these two cylinders that we can make based on that. Okay, so when we look at tall versus short, okay, the tall cylinder has a volume of 63.0 inches. The short cylinder with the bigger base has a volume of 81.8 inches cubed. So the cylinder that has the larger volume is the short cylinder. Okay, we got about 2 more here, going through and just really looking at those most missed problems overall. Okay, so Sylvia has just discovered that the valve on her cement trunk failed during the night and that all the contents ran out to form a giant cone of hardened cement. To make an insurance claim, she needs to figure out how much cement is in the cone. So we have the circumference of the base. So once again, you can see we're going to have to find radius first. And then once we find the radius, then we can calculate the volume. So we have a circumference of 44 feet. Okay, that is 2 pi r. So we're going to divide both sides by, remember, parenthesis 2 pi. Okay, that's an important part. Or what you can do is do 44 divided by 2, enter to get 22, and then do 22 divided by pi. You know, so that is a secondary option. And we get a radius. There is a small decimal at the end, but it's basically 7 feet for the radius of that cone. So now when we want to find volume, once we have the radius, we're plugging into our volume formula, 1/3 pi r squared times the height of 5. Okay, and we're going to multiply this all out using the pi value. So 1 divided by 3 times 7 squared times 5 times pi. And we get a volume rounded to the nearest cubic foot. I'll put the decimal value in first. So you can check your answer, 256.56. Rounding that to the nearest foot, 257 cubic feet. So 257 cubic feet of concrete is how much drained out of this truck. Okay, last piece that we have here. Okay, looking at the pool problem, because I know a couple people have asked me questions about this pool problem here. What we really have to be careful of is making sure that all of our values are properly stated. Okay, so now we've got this situation. We've got a child's wading pool. And notice that the picture doesn't quite match the situation, but we gave you the visual here. So let's ignore the picture here. Okay, this is actually one we've done back in a previous unit. Okay, so we've got the wading pool diameter of 7 feet. So that means that the radius of the pool is 3.5 feet, and it's 6 inches deep. Okay, so it's a very small pool. Like we said, a wading pool. So the height of this cylinder has to be converted to feet. So it's 0.5 feet, because 6 inches is half of a foot. How many gallons of water can the pool hold? If 1 cubic foot of water is about 7.5 gallons. So the first thing that we have to do is we have to find the volume of water, and then we can figure out how many gallons it holds based off of that. So volume of a cylinder, area of the base, radius squared pi times the height of the object. Okay, so we're going to multiply that all out to get the volume first. 3.5 squared times 0.5 times pi, and we get 19.24 cubic feet. So that's how much water is in there. Okay, now we want to turn this cubic feet of water into gallons. Okay, so now this is where we use our ratios that we've used. 1 cubic foot is 7.5 gallons. So 19.24 cubic feet is X gallons. So X equals 7.5 times 19.4. And we get 144.3 gallons. Okay, so we've got that volume measurement. We take that volume and multiply it times the ratio value for converting cubic feet to gallons. All right, well, that is our most miss for the unit. Hope things are going well, and good luck on your unit test. Have a good day.